All right, next is the binomial model. The binomial model is used when you are examining the number of successes in a set number of trials. This is when you are counting how many yeses you have in a set number of trials. We did this exactly when we looked at Randy's simulation. If you remember, Randy shot 30 shots and we counted how many did he make in with an 80% shot rate. That was the binomial model. We were simulating it, but that was the binomial model. Okay, the number of successes is when you count the yeses in a set number of trials. We have two parameters for the normal model. Remember, parameters are just what kind of define the model. For normal model, we had mu and sigma. For the geometric model, we just had p. And the binomial model has n and p. Those are the two parameters. N is the number of trials. P is the probability of success. So for Randy, if you think back to Randy's simulation, N was 30 and P was 80%. That was his shot rate, success rate. So every binomial model is based off of N and P. This is how we name the model, binom NP. So we can now add to our list binom NP. Another model. 3 models now, normal, geometric, and binomial. Binomial probability, N is the number of trials. P is the probability of success. Q, which is 1 minus P, is the probability of failure. We'll let X be the number of successes in N trials. Now, the way you find the probability is way more complicated. The geometric model was actually pretty simple, where you just had Q to the X minus 1 times P. So if X was 6, you had Q to the 5th and then P, always. If it was less than or equal to, like this problem, got a little more complicated, but each individual one was not that hard. It was just make a long list. This one's going to be more complicated, and it's new notation. This is on your formula sheet. So this is on your formula sheet. However, you're not really going to use this formula all that often. I've seen one test with one multiple choice question where the answers were set up in this format, so you needed to kind of at least recognize that it was a binomial model. But as far as actually calculating binomial probability, we're just going to use our calculator. But what these symbols here, this is new symbols, this parentheses and N and X, this is actually a combination problem. This is you figuring out how many different ways can you have X successes in N trials. This is a whole nother lesson for me to teach you how to actually do this. You can just do it in your calculator. If you ever need to do it, I'm going to show you real fast, but you don't need to do it like this. This little symbol right here, let's say N, like Randy, N was 30, and let's say how many different ways can he make 20 out of 30 shots? In my calculator, I would hit 30, math, probability number 3, NCR, 20. So this is figuring out how many different ways can Randy make 20 out of 30 shots. See, that's a huge number. This is why we don't ever really do these by hand. What that means is he could make the first 20, or he could make the last 20, or he could make the first one, skip the next 9 or so, and then make the last 19. If you kind of think, those are adding up all the different ways he could make 30 shots, and that's a huge number. This is why we use our calculator. All right, next we're going to have the mean, the expected value, or the mean, which is NP. Remember, we did that for Randy. 30 times 0.8 was 24. That's how many we expected him to make it. But just like we discovered when we did Randy's simulation, he didn't always make 24. Sometimes he made more, sometimes we made less. And so there was a measure of standard deviation. We were able to measure how much we expect the number of successes to be off from this mean. Obviously, the further you get from the mean, the less likely it is that that's going to occur. This gives us an idea of how far off the standard deviation should be. Does anyone remember what the standard deviation was for that day when we did a bunch of trials? I believe it was around 2 point something. So let's just plug these numbers right here into our calculator for the standard deviation. Square root of n, 30, p, 0.8, q was failure, 0.2. And that's what it was. Remember, we simulated, so we weren't perfect, but we were fairly close to that in our live histogram that we did that day. We will primarily use the calculator for binomial problems, not this formula. This formula is rather complicated. You do need to be able to use the formulas for the mean and the standard deviation. These formulas here are important. They are on your formula sheet. You do need to know when and where to use them.